Sample 3, Video 1. There are a couple of things I would like to mention in this video. The first being I have upgraded the method of recording the microorganisms, and this difference of quality can be seen throughout the video. The second, I would like to touch upon the significance of the location where I gathered this sample. I obtained this sample from Ginnie Springs in Gilchrist County, Central Florida, and it is one of 11 springs in the area. Ginnie Springs has become a popular tourist attraction because of its crystal clear water and limestone sediment bottom. This limestone sediment is rich in calcium carbonate and sand. However, the most important thing to know about Ginnie Springs is it's considered a polluted spring based on its nitrate concentration. The FDEP has placed a limit of 0.35 milligrams per liter regarding nitrate concentrations in natural springs. In 2019, Ginnie Springs recorded approximately 1.4 milligrams per liter of nitrates. These increased nitrates have a significant impact on protist and bacterial colonies. Usually, nitrates in aquatic environments are maintained by the microorganisms inhabiting the sediment. By being exposed to nitrate pollution, it is less likely for the microbiome to recycle decaying organic materials, which can potentially lead to sediment acidification. Knowing this, here are some of the microorganisms I encountered in this sample. At first look, I believe this to be the infamous Paramecium caudatum. Upon further examination, I determined it was in fact not a Paramecium, but still a ciliated protist, and with a distinctively hooked oral cavity. Due to this and the fact that my sample was collected from freshwater sediment, I've classified this organism to be a Loxides. They are long, flattened ciliates of the Caryorelictia class that live in freshwater sediment and, interestingly enough, are capable of respiration using nitrates. Most are omnivorous and contain symbiotic zoochloreae. I also encountered this microanimal that I mistook for a worm until it was pointed out that this was a ciliate as well. More specifically, a hypotrich ciliate. The organism's body is flexible, which allows it to maneuver through the sand particles and quickly change directions. To me, it looks most like the Uncinata. However, I am unsure of this classification and was unable to examine the cilia of this organism. Its brown color is most likely due to food granules, and since this was recorded at a low magnification, these granules cause the organism to appear brown. If you've watched my Sample 1 Video 3 post, you can most likely recognize this organism. This is the Dicrenophorus rotifer. In the previous video, I noted that my specimen lacked the characteristic corona of the Rotifera genus. But with the new camera quality, the corona are visible, and if you look closely, you can see the vortex it creates. The rotifer's features are also more clearly distinguished, like the single foot, the red eye spot, and its most prevalent characteristic, the hardened mandible. The vast majority of organisms I encountered were too fast to capture and appeared to move by jumping, very similar to the Stylonychia I encountered. When placed in a 3% methyl cellulose solution, it was easier to identify these fast-moving ciliates as Pleuronema. They are free-living, oval-shaped, and are known to move in jumps. Some eat bacteria and algae as well as smaller diatoms. I hope you enjoyed this video. Once again, all of my resources that I utilized for this video are linked in the description below.